Hey everyone, so when we think about science, we usually think about a big book of facts, right? But what's way more interesting is how we get those facts. Today, we're going to crack open the scientist's toolkit and see exactly how an idea goes from just a simple question all the way to a solid conclusion. It all starts with just wondering about stuff. Have you ever looked at your garden or maybe a sad-looking houseplant and thought, why is this one thriving, but the one right next to it looks terrible? That little moment of curiosity, that's the spark. Or how about this one? You're in the kitchen, you're making pasta, you toss some salt in the water, and it suddenly boils differently. Why does that happen? It's these little everyday questions that are actually the seeds of all scientific discovery. So to make this whole process really stick, we're going to follow an experiment from start to finish. And we're going to tackle a delicious question. What is the secret to making the perfect loaf of banana bread? Yeah, we're going to follow this from the very first idea all the way to the, hopefully, tasty conclusion. Okay, let's dive in. First things first, perfect is kind of vague, right? My perfect might not be your perfect. So how do we take a big, fuzzy question like this and turn it into something we can actually measure and test in the real world? Well, in science, we call that testable idea a hypothesis. It's basically a clear, focused statement about how something might work. It's our best educated guess before we even start. So for our banana bread, a really solid hypothesis could be something like, a higher baking temperature will cause the banana bread to rise the most. See? It's specific, we can measure the rise, and we can totally design an experiment to see if we're right. Now hold on, before we even think about preheating the oven, we need a blueprint. We need a plan of attack. And in science, that means figuring out the right type of investigation for the question we're asking. So we've got a couple of main options here. On one side, you have a controlled experiment. That's what we're going to do. It happens in a super controlled setting, like our kitchen, where we get to change things on purpose. On the other side, you've got an observational study. That's more about just watching things in their natural habitat without messing with them. Like a biologist watching frogs by a pond. For our bread, we need to control things to get a clear answer. So a controlled experiment is definitely the way to go. And this right here, this gets to the absolute heart of a good experiment: control. If we want a result we can trust, we have to be really, really careful about what we change, what we measure, and, this is the big one, what we keep exactly the same. This is where we need to talk about variables. First up, you've got your independent variable. It's the one thing the experimenter, that's us, intentionally changes. I love this little memory trick. It's what I change. It's the cause we're testing. So in our banana bread experiment, what are we changing on purpose? The oven temperature. That's our independent variable. Okay, so if we're changing something, we have to measure the result, right? That's the dependent variable. It's the effect. Its value depends on whatever we did with the independent variable. For our experiment, it's super simple. We're going to measure how high the banana bread rises. That's our dependent variable. And last, but definitely not least, are the control variables. This is everything else. And honestly, this is usually the trickiest part of setting up a good experiment. To make sure our test is fair, every single other thing has to stay constant. I mean, think about it. If we use a different recipe or a different sized pan for each loaf, how would we know if it was the temperature that made the difference or something else? These controls are what make our results actually mean something. All right, so let's put it all together for our banana bread experiment. Our independent variable, the one thing we're changing, is the baking temperature. We'll try 3 different ones. Our dependent variable, what we're going to measure, is the final height of the bread. And our control variables? Well, that's the whole shebang. The recipe, the ingredients, the pan size, the baking time, all of it has to be exactly the same for each loaf. Okay, the kitchen smells amazing, the baking is done, and now for the really fun part. Let's look at the results. It's time to see what our data is telling us. So here's what we got. We laid out our results in a simple little table. The loaf at 375 degrees, it came out to 7.5 centimeters high. The one at 400 degrees got up to 9 centimeters. And then at 425, it actually dropped a bit to 8.2. This right here, this is our raw data. But, just looking at a table of numbers can be a little meh. It's hard to see the story. But when you visualize it, like in this bar chart, bam, the story just pops right out at you. You can instantly see that middle bar, the one for 400 degrees, is the tallest. The chart makes the conclusion impossible to miss. 400 degrees seems to be the absolute sweet spot for getting the best rise. What we've just found here is a textbook example of a correlation. It's just a fancy word for a relationship, where changing one thing, in our case the temperature, directly affects another thing, the height of the bread. It's clear this isn't just random luck. So cool, our little kitchen experiment totally supported our hypothesis. But let's zoom out for a second. In the grand scheme of science, one single experiment is just that, a single data point. Real scientific knowledge is built by piling up evidence from lots and lots of experiments, all done over time. And that actually leads us to a really fundamental and kind of surprising truth about science. There's this great quote that sums it up perfectly. Science is constantly improving people's understanding of nature. However, science will never be finished, and nothing in science can ever be proven once and for all. Wow. So what that means is that science is always a work in progress. It's a process of getting closer and closer to the truth, not a big book of final, unchanging answers. It's all about the journey. This also brings us to 3 words that people mix up all the time: hypothesis, law, and theory. They're like rungs on a ladder of scientific certainty. A hypothesis, that's our starting point, our untested idea, like, I run faster with music. A scientific law, like the law of gravity, is a super well-tested description of a pattern. It tells you what happens. If you drop an apple, it will fall. But it doesn't tell you why. That's where the real powerhouse comes in, a theory. A scientific theory, like plate tectonics, is this massive, broad, deeply tested explanation for the how and the why behind a whole bunch of stuff. It's the ultimate prize in science. So you can really see the path here, right? You start with a simple, testable guess, a hypothesis. If tons and tons of experiments show the same pattern over and over again, that pattern might get called a law. It describes what happens. But the ultimate goal, the grand prize, is building a comprehensive theory that explains the why and the how behind that law. It's a thing that ties it all together. So there you have it. We went from wondering about banana bread all the way to what a scientific theory really is. And I think the coolest takeaway is that the scientist's toolkit, it isn't just for people in white lab coats. It's a way of thinking that any of us can use. So I'll leave you with this question. What's a simple, everyday question that you're curious about that you could answer with your own little experiment?